Section 11.2 is zeros of polynomials part 2. So in the last section we discussed synthetic division. Next we're going to discuss finding zeros of a polynomial and the multiple ways to do that. So a zero of a polynomial function f is a value k such that f of k equals 0. So let's look at this simpler example. So here we have a quadratic equation, a degree 2 polynomial. And I know that this factors to x minus 2 times x minus 3, giving us zeros of 3 and 2. So that's where our graph crosses the x-intercept. Let's find f of 2 and let's find f of 3. So f of 2 would be 2 squared, let's change colors, 2 squared minus 5 times 2 plus 6. Well, 2 squared is 4, 5 times 2 is negative 10. Plus 6, this adds up to 0, right? So f of 2 is 0 because that's when y equals 0, right? When our graph crosses the x-axis, that's when x is something, but our y value is 0. And f of x is the same thing as y. Tying everything together. See, this is where we've been building to all semester. Next, let's find f of 3. 3 squared minus 5 times 3 plus 6 is 3 squared, which is 9, minus 15 plus 6, which is also 0. Very, very interesting. Keep that in mind as we go forward. Let's talk about our factor theorem. So for any polynomial f of x, x minus k is a factor of the polynomial if and only if f of k equals 0. Okay, this means f of x is g of k times x minus k for some polynomial k. It has a remainder of 0. In our previous example, right, we found that x minus our k's was a factor because f of k was 0. So a zero of a polynomial function f is a value k such that f of k equals 0. So let's go ahead and determine if k equals 1 is a zero of the function f of x is x to the fourth minus 5x cubed plus 10x squared minus 10x plus 4. So let's take f of 1, which is 1 to the fourth minus 5 times 1 cubed plus 10 times 1 squared minus 10 times 1 plus 4. So I get f of 1 is 1 minus 5 plus 10 minus 10 plus 4. Well, this is going to give us that f of 1 is 0. This means that x minus 1 is a factor of f of x. We could now use synthetic division to simplify this. Why don't we go ahead and do that? So I have my k of 1 is a 0. I've got 1x to the fourth minus 5x cubed plus 10x squared minus 10 plus 4x. And I pull down that first term. 1 times 1 is 1. Negative 5 and 1 is negative 4. 1 times negative 4 is negative 4. 10 and negative 4 is 6. 1 times 6 is 6. Negative 4 and 6 is negative 4. 1 times negative 4 is negative 4. Negative 4 and 4 is 0, right? We knew we were going to get a remainder of 0 because k is 1 is a perfect divisor. So I can rewrite f of x as x minus our k, which was 1, times x cubed minus 4x squared plus 6x minus 4. And if I wanted to, I could keep going and looking to try and find other zeros of this quotient. And I'm going to show you guys how to do that in this chapter, this section of this chapter. So let's take a look. I know I've got f of x is x to the fourth minus 5x cubed plus 10x squared minus 10x plus 4. This was the polynomial that we were looking at in the last example. Now I want to determine if k equals 2 is a factor. Okay, f of 2 is 2 to the 4th minus 5 times 2 cubed plus 10 times 2 squared minus 10 times 2 plus 4. So I have f of 2 is 16 minus 40 plus 40 minus 20 plus 4. And lo and behold, that would also be a 0. So now I know x minus 2 is also a 0. Well, I just found previously that f of x is x minus 1 times x cubed minus 4x squared plus 6x minus 4, right? This is what we did on the previous page. Now, I know since x minus 2 is also a 0, it must be a factor of this. So we can do synthetic division again. We must divide to keep simplifying this. I've got 2 times 1x cubed minus 4x squared plus 6 minus 4. I didn't need that plus sign. My bad. I pulled down my first term. 2 times 1 is 2. Negative 4 and 2 is negative 2. 2 times negative 2 is a negative 4. 6 and negative 4 is a positive 2. 2 times 2 is 4. Our remainder is 0. Okay, so now I can write my function f of x as our original first 0 we found, our second 0 we found, times x squared minus 2x plus 2. Well, I know how to factor x squared minus 2x plus 2 by saying, okay, what are the factors of AC that add up to B? Well, that's going to be negative 1 times negative 1 and negative 1 plus negative 1. So that gives me f of x equals x minus 1 times x minus 2 times, this is x minus 1 and x minus 1, right? Oh, that's 2 more of them, so I've got x minus 1 cubed. This is our fully factored degree 4 polynomial. Now, let's check if k equals minus 2 is a 0 of our function we've been working with this entire time. Now we know negative 2 is not a factor, right? Because we fully factored this into f of x is x minus 1 cubed times x minus 2. And because it's x minus 1 cubed, we would say that has a multiplicity of 3, just a fun word for us to know. But we know negative 2 is not a factor, but let's see what happens. If I have f of negative 2, that gives me negative 2 to the 4th minus 5 times negative 2 cubed plus 10 times negative 2 squared minus 10 times negative 2 plus 4. So f of negative 2 is 16 minus 5 times a negative 8 plus 40 plus 20 plus 4. So f of negative 2 is 16 minus 40 plus 64. Well, that means f of negative 2 is going to equal 40, and this is not 0. So negative 2 is not a factor.